and papers. Mukherjee realized that in order to make his science college great, he would need people like this. Meanwhile, a very different revolution was taking place in Europe. The old physics of Newton and Maxwell was being turned on its head.
A lot of revolutions were taking place in science, particularly physics. And the old world of classical physics was kind of breaking down.
The first revolution was in the atom. The Greek philosopher Democritus had first proposed that the universe was made up of atoms in the 5th century BC. Everyone assumed that atoms were solid, indivisible objects. Then, in 1897, J.J. Thomson discovered that the atom was not solid at all, but made up of tiny corpuscles. The billiard ball model of the atom was shattered, and science would never be the same again. The second revolution was in light.
Newton said light consists of particles like bullets, and he constructed a very successful theory. Then somebody discovered wave-like property of light, and that happened in the 19th century. Then the notion of corpuscular theory of light was abandoned.
The third revolution was in radiation. When a hollow black body was heated, it was meant to radiate spectrum at an infinite rate along a straight line. But this did not happen, and a curve resulted that seemed to come back on the spectrum. No one could explain this.
Europe was completely puzzled, and then Planck somehow wrote down a formula which fits this curve exactly and accurately fits all the experimental data. Having written down that formula, he wanted to derive it from some theoretical framework.
Max Planck came to the conclusion that energy was being let out in discrete energy quantities or particles. He called these particles quanta. The equation came to be known as Planck's law. This was the beginning of the quantum age. Then 3 amazing developments occurred. Einstein demonstrated that light was both a wave and made up of particles he called light quanta. Lord Rutherford discovered the solar system model of the atom, with a dense positive nucleus and electrons spinning around it. And finally, Niels Bohr demonstrated that those electrons could only move at the quantum energy levels predicted by Planck.
So these 3 great shots in the dark had already been made when Bohr entered to fire the final and 4th great shot in the dark.